The quantity theory of money assumes velocity is determined and stable. However, if people fear a situation where maybe the economy is going into a recession, they lose their job, don't spend any money, they hoard their money. Maybe they pull their money out of the bank because they fear a bank run too, and they stash it under their mattress. Well, that money is not being circulated, so the velocity in that situation would drop dramatically. However, when people feel good about the future, they start pulling more and more dollars out of their mattresses. And those dollars start circulating more quickly through the economy, and the velocity picks up. Samuelson said this regarding velocity: "It is not constant because you can lead a horse to water, but you cannot make him drink. You can force money on a system in exchange for government bonds, its close money substitute. But you cannot make the money circulate against new goods and new jobs." Austrian economist Henry Hazlitt noted that when money is newly introduced, the price level increases by a smaller proportion than the increase in the supply of money. But that when the money has been in circulation for a while, the price level has increased by a greater proportion than the money supply. This is due to fear that the inflation will continue into the future, and that the value of the monetary unit will fall further. It's not the velocity of money that determines the value of currency, but rather the sum of individuals' value of the currency that determines the velocity of money. Ludwig von Mises said, "The main deficiency of the velocity of circulation concept is that it does not start from the actions of individuals, but looks at the problem from the angle of the whole economic system. This concept itself is a vicious mode of approaching the problem of prices and purchasing power. It is assumed that, other things being equal, prices must change in proportion to the changes occurring in the total money supply. This is not true." Mainstream economist defines inflation as a general increase in the prices of products. Now, this is a way you can very quickly calculate an inflation rate. You take the price level today, you divide it by what it was a year ago, and then you subtract 1 from that, and then you convert it into a percent. Now, inflation, according to Fisher's equation of exchange, if real GDP falls and money times velocity does not change. Or maybe real GDP is constant and dollars start circulating more quickly through the economy with the supply of money constant. Or velocity is constant, real GDP is constant, but central bankers are printing money to buy government securities. Now, there are several kinds of inflation that mainstream economists have defined. There's demand pull inflation, cost push inflation, excessive growth in the quantity of money inflation. Demand pull inflation is where aggregate demand is strong, and as a result of strong aggregate demand, it pulls us from a situation where real GDP equals its potential value of $15 trillion with a price level of 14.5. Now remember, at such a point, the natural rate of unemployment and the unemployment rate are equal. Something triggered aggregate demand to shift outward. Maybe it was politicians passed a temporary tax cut, or they increased government expenditure temporarily. Maybe they decide to pave all the roads in the month leading up to the election to assure their re-election. Or maybe it's a result of exports being really, really strong because a large country, a very large country, a large economy is growing rapidly, and they have all this extra money and they're buying our products. So maybe exports explode. It could be the fact that maybe people feel really good about the future. They expect their incomes to be really high in the future, so they start spending a lot. Or maybe interest rates came down, and so business investment expenditure increases. Or maybe more people buy homes. So for whatever reason, aggregate demand shifts out. Well, that results in some inflation. The price level goes from 14.5 to 15.5. So that is inflation. The inflation rate from point A to point B is found this way. taking the ratio of these two numbers, 15.5 divided by 14.5, subtracting off 1, and then multiplying by 100, you get 6.9%. So there's some inflation there, correct? Now, if the economy is at this point, unemployment is really, really low. Because unemployment is below the natural rate, firms are having trouble staffing production lines. So they either pay their employees overtime wages, or they bid up wages as they try to attract workers from other firms to join their firms. So for example, General Motors tell Ford workers, hey, come work for us. We'll give you better benefits and better pay. And Ford is doing the same thing. So there's a bidding war for labor, and wages are bid up. And when wages are bid up, the marginal cost of production rises. When the marginal cost of production rises for every firm, the short and aggregate supply curve shifts upward. So the short and aggregate supply curve shifts up along this new aggregate demand curve until the output gap is closed. At this point right here, the natural rate of unemployment and the unemployment rate have once again equated. So we get a second bout of inflation. From point A to point C is 16.5 divided by 14.5 less 1. Convert it into a percent and you get 14.8%. So this is what economists refer to as demand pull inflation. So prices rise. Well, why did prices rise? According to classical economists, real GDP is fixed. Maybe velocity increased, or the quantity of money increased. Remember, the velocity of money is held constant in the quantity theory of money. So maybe what happened is politicians wishing to get reelected ran a huge budget deficit which overstimulated aggregate demand. Well, in order to pay for that budget deficit, the Fed has to print money and buy bonds either directly from the Treasury or the Fed purchases them through banks. In a free market economy where there are no government interventions, in the absence of food stamps, in the absence of pro-labor union policies, in the absence of minimum wages, in the absence of all those market protections and subsidies to corporations and individuals and colleges, in the absence of all those government interventions, I posit that there's really no such thing as demand pull inflation. Why do I say that? In a free society where there is much competition, there is innovation, more so than an economy heavily regulated and restrained by government intervention. In a free society where people are free to fail, succeed, and there are no moral hazards created by government welfare programs to corporations, colleges, banks, and individuals, a low unemployment rate at point B would result in higher wages. However, think about that. For example, if McDonald's was having a hard time staffing its restaurants, it could hire people away from Burger King, but it had to pay a much higher wage and possibly pass those higher wages off onto the Big Mac consumer in the form of a higher price. But McDonald's might have competition from people cooking meals in their homes. Maybe people decide instead of eating a Big Mac that's now $2 higher, they'll just make a hamburger at home. So people have choices. Maybe they buy a frozen hamburger produced in a low-cost country who freezes a hamburger and then exports that to the United States. So maybe instead of buying the Big Mac, they buy a frozen Big Mick from Thailand. When you have an open society and there's trade with other nations, there's global competition. Maybe in the short run, it'll hire labor at a higher wage. But over the long run, it's just not going to take it. What it can do over the long run is innovate. So maybe what McDonald's does is that it gets rid of the labor that is necessary to clean bathrooms, for example. And instead of having humans cleaning bathrooms, the door shuts every 15 minutes, locks, and it self-cleans like a dishwasher. Maybe they go to iPads. Maybe they have iPads at the counter instead of humans. And you walk in and you type in your order on iPads. So those are ways that McDonald's could get around paying higher wages. When that kind of innovation occurs, right, McDonald's is shedding its workers. is not demanding as many workers. So the unemployment rate comes up naturally through innovation and adopting labor-saving technologies. In addition to that, new industries are created. The self-cleaning bathroom industry expands rapidly. So what ends up happening in the Austrian world in a free society is that both short-run aggregate supply and long-run aggregate supply shift outward to meet aggregate demand. So instead of going from A to B to C, the economy goes from A to B to D. And if that happens, the inflation rate is 0. So I actually want the Fed to do nothing when unemployment's low. I do not fear higher wages. I think higher wages tell firms to start innovating. And if that happens, short aggregate supply and long aggregate supply shift to the right, which keeps prices relatively stable. Cost push is another mainstream concept regarding inflation. The way this works is there's a supply shock. Remember, the short aggregate supply curve is an aggregate marginal cost curve. When there's a supply shock, maybe there's a flare up in the Middle East and all of a sudden people expect gasoline prices to rise, they spike up, which raises the marginal cost of production in the short run. So the short run aggregate supply curve shifts upward. When marginal cost of production shift upward, the short run aggregate supply curve shifts upward. It's called a decrease in short run aggregate supply because if you hold the price level constant and you go from what the supply curve was to what it is, you get a decrease in the quantity of real GDP supplied. The economy moves from point A to point B. From point A, the price level is 14.5. At point B, the price level is 15.5. So the inflation rate is 15.5 divided by 14.5, subtract 1, multiply by 100, you get 6.9%. But now, at this point here, unemployment is high. Unemployment is higher than the natural rate. Before the supply shock, the unemployment rate was equal to the natural rate. After the supply shock, real GDP falls below what it should be, and unemployment rises above its natural rate. So now we have a situation where unemployment is high. So prices rose and real GDP fell. So maybe that implies nominal GDP remains constant. Remember, M times V equals nominal GDP. Nominal GDP is price level times real GDP. What's going to happen when we're at point B? Why does the supply curve shift back down to the red short-run supply curve? Well, at this point here, recall that unemployment is really, really high. When unemployment's really, really high, people are more desperate in a free society. So they're willing to take a huge pay cut. If they're willing to take a huge pay cut, and that's the case for a lot of workers in the economy that are out of work, then the marginal cost of production falls. So the marginal cost of production will fall until this gap is closed. That's an increase in supply. There are so many things that inhibit wages from falling. There are minimum wage laws. There are union rules and regulations. Union contracts. If you're unemployed, you collect unemployment insurance. You enroll in food stamps. You enroll in Medicaid. For all those reasons, you're not as desperate to go back to work. So maybe you wait it out. So unemployment remains persistently high in a world of all these market interventions by government. The inflation rate is 0%. The more freedom an economy has, the more quickly the short aggregate supply curve shifts. And if it shifts relatively quickly, when unemployment is really, really high, and people are desperate for work because there's no assistance out there, then there is no inflation. But again, we live in a society where labor markets are heavily regulated. If velocity of money is fairly constant in the short run, and the natural rate of unemployment equals the unemployment rate, and real GDP will equal its potential. If money rises because the Fed prints a bunch of money to buy government bonds due to the Congress and the president may be trying to buy elections with tax cuts and increased government spending, which overstimulates the aggregate demand curve, then the short and aggregate supply curve increases too, because at this point, unemployment is really, really low. And there's a bidding war for labor, so wages rise. So we end up at this point up here. The increase in money that was needed to pay for the stimulus that pushed aggregate demand out to here ends up resulting in inflation. The resulting inflation is found by dividing 16.5 by 14.5, subtracting 1, and then multiplying that by 100. So this is the classical view of inflation. Inflation results from an excessive growth in money. Now, who agrees with that? Milton Friedman, writing in The Counter-Revolution in Monetary Theory, says, inflation is always and everywhere a monetary phenomenon, in the sense that it is and can be produced only by a more rapid increase in the quantity of money than an output. Assuming V is constant in the short run gives the quantity theory of money. So we're going to hold velocity constant. Nominal income, nominal GDP, is determined by the changes in the quantity of money. So if this increases, nominal GDP goes up. Now the above can be written as follows. Two products that are equal. You can write the equality of two products as the sum of percent changes equaling the sum of percent changes. To demonstrate how this works, let's first multiply 212, the price level, times real GDP, $15 trillion. 212 times 15 is 3,180. Does that equal 1590 times 2? The answer is yes, that is true. If you do the same thing with 221 times 15.3, you get the same thing as 1690.7 times 2. So this times that equals this times that. This times that equals this times that. So we verified this. Now, let's calculate the percent change in the price level from 2012 to 2011. Remember the very easy way to do this. We take 221 divided by 212. We subtract that ratio from 1. You get 4.2%. I haven't multiplied that by 100 yet. The percent change in real GDP is 2%. The percent change in money is 6.3%. And because velocity is being held constant here, the percent change in velocity is 0%. So 4.2% plus 2%, that's 6.2%. That is roughly equal to 6.3%. Hence, the quantity theory of money is also a theory on inflation. The inflation rate equals the growth rate of money minus the economic growth rate, the percent change in real GDP. Here we have U.S. inflation and money growth rates by decade. And here we have inflation versus money growth. It's almost a one-for-one relationship. So the way you interpret the 0.89 is, if the growth in money goes up by 1 percentage point, the inflation rate goes up by nearly 1 percentage point. This chart graphs inflation and M2 money growth. The author of our book says high money growth rates are sometimes associated with low inflation rates. So right here, for example, we have a high money growth rate and inflation is low. We have high money growth rate and inflation is low. High money growth rate and low inflation. High money growth rate and low inflation. However, that's a short-run view of this relationship. The long-run view is high money growth rate is associated with accelerating inflation. High money growth rates is associated with accelerating inflation rates. High money growth is associated with accelerating inflation. If you take a longer perspective of it, you kind of see Fisher's point of view. If you look at it from the short-term perspective of the author, you go, oh, Fisher's wrong. Government expenditures is paid for by raising tax revenue, or Treasury can print money. In the U.S., the Fed buys bonds now directly from Treasury. Treasuries can sell more bonds. If the deficit is financed by selling bonds to the public, there's no effect on the monetary base, reserves plus currency in circulation, and on the money supply. If the deficit is financed by the Fed buying bonds from banks, the monetary base and money supply increase. Which is kind of weird because we haven't had any inflation according to government figures since 2008. A lot of people say, hey, the Fed should do more because we haven't had any inflation. I perhaps think that when the Fed is printing a lot of money, other central banks print a lot of money. And since we were the safe haven currency before that happened, and if we print a lot of money and other banks print a lot of money, we're still, relatively speaking, the place you go for safety. So in a sense, we've become the least worst currency maybe in the world, which is maybe why we don't have inflation in the United States. Before the Fed, $1 could buy 11% more goods in 1912 than it could in 1776. However, $1 buys 95% fewer goods in 2008 than it did in 1913 when the Fed was organized. So essentially what the Fed has done in the last 100 years, it's taken the US dollar and turned it into a penny. This is the Consumer Price Index. So the Fed was pretty good with managing the CPI, apparently from 1913 to 1970. But if you were to ignore this part of the graph and you look at the CPI, 40 in 1970, and what about 10 in 1910? Although it looks pretty tame when you include this part of the graph, going from 10 to 40 in what looks like 60 years is pretty good inflation. 40 divided by 10 is 4. 4 minus 1 is 3. So we're talking about a 300% increase in the CPI from here to there. So what looks like pretty tame inflation really is not. Now when you go from, what about 230 and 10, 230 minus 10 is 220. 230 divided by 10 is 23. 23 minus 1 is 22. Multiply that by 100, and you have 2,200% inflation from 1913 to 2013. So that's kind of interesting. Hyperinflation is a period of high inflation. Larry Ellen's The Encyclopedia of Money discusses several hyperinflations in the world's history. The one I find interesting is the Bolshevik Revolution. According to him, prior to 1917, prices rose 2 to 3 times faster than wages. After 1917, prices rose by 92,300% from 1913 to 1919. But from 1913 to 1923, prices rose 64.823 billion percent. In post-World War I Germany, in 1914, there were 6,323 million marks in circulation. By 1923, there were 17.4 million in circulation. A newspaper costing 1 mark in May 1922 cost 1,000 marks 16 months later, and 70 million marks a year and a half later. At its worst, customers rolled wheelbarrows full of money to the grocery store. Customers in restaurants negotiated the cost of meals in advance. Printed money was baled like hay to heat one's home. It took about 4 days for prices to double. Workmen are given their pay twice a day now, in the morning and in the afternoon, with a recess of a half hour each time, so that they can rush out and buy things. For if they waited a few hours, the value of their money would drop. The time it took for prices to double in 1994 Yugoslavia was 33.6 hours. In 2008 Zimbabwe, 24.7 hours. In 2008 Zimbabwe, you buy a Coke for $100 on Tuesday. That Coke on Wednesday is $200 because prices were doubling about every day. As we mentioned in video 1, the Fisher effect is the relationship between the nominal rate of interest and the real rate of interest. The nominal rate of interest in the Fisher effect equals the real rate of interest plus the inflation rate. If you look at this diagram here, you see nominal interest rates versus inflation rates. In this diagram, you have nominal interest rates versus inflation rates. This is using international data, and this is using U.S. data through time. So we have two equations here. We have the U.S. relationship between its nominal rate of interest and its inflation rate. And this says what? This coefficient is 0.71. When the real rate of interest rises by 1 percentage point, the nominal rate of interest rises by 0.71, which is not that close to 1. But internationally, using international data across countries, averaged for the years 1996 to 2004, the slope coefficient in this Fisher equation is 0.86. So using international data averaged over a longer period of time, what you see is a 1% in inflation leads to a nearly 1 percentage point increase in the nominal rate of interest. So maybe the moral of the story is, over the long run, maybe Fisher had something to his theory. Using current inflation assumes inflation does not change. Future real rates of interest will be different from what it was expected to be when loans were signed. Borrowers do better and lenders do worse when loans are repaid with devalued money. In an uncertain world, the Fisher effect must account for this uncertainty. So we put an E in the subscript of the inflation rate. The Fisher effect becomes the real rate of interest plus the expected inflation rate. Now, there are some ways you can estimate expected inflation rate. If you take the difference between yields on TIPS, Treasury inflation protected securities, and conventional treasuries, the TIP spread. So for example, if the difference between a 10-year TIPS and a Treasury is, say, 3, then the market is expecting inflation to be 3 in 10 years. If I see TIPS and Treasuries widening, and the Fed has been very loose with its monetary policy, I form an expectation that the Fed's going to tighten, which usually ends in a recession. 1991, before that, the Fed raised interest rates substantially. Before 2001, the Federal Reserve raised interest rates substantially. And then before 2008, the Fed raised interest rates from 1 to about 5% in about a year or so. We're going to use the equation of exchange to derive money demand. Now, this is an equivalent version of Fisher's equation of exchange. In the equation of exchange, M is times V, and P is times Y. We is cross multiplied. You can think of this as real money balances. And then Y is real GDP divided by velocity. Now, in the example that's going to play out for the rest of this video, we're going to assume the price level is 1. Real GDP is $15 trillion and velocity is 1.5. The real money balance is what? $10 trillion or $10,000 billion. And notice it's not a function of the nominal rate of interest. Say the interest rate is 15%. Real money balance, according to Fisher, is $10 trillion or 10,000 billion. If the nominal rate of interest is 2.5, the real money balance is $10 trillion or 10,000 billion. In Fisher's world, money demand is a perfectly inelastic curve. To Keynes, people held money for transactions purposes, precautionary purposes, and speculative purposes. The transactions motive for holding money is, according to Keynes, well, he agreed with the quantitative theory that the transactions component is proportional to income. He later recognized that technological advances will create methods for payment technology, which affects money demand. The precautionary motive for holding money. Keynes also recognized that people hold money as a cushion against unexpected wants, which is proportional to income. So I is negatively related to the precautionary demand for money because as it increases, the opportunity cost of holding money for precautionary reasons rises. The speculative motive for holding money. Keynes also believed people choose to hold money as a store of wealth. In his liquidity preference function, denoted L, Keynes puts the three motives together. He recognized that people make decisions based on the real value of the money they hold, M divided by P. He identified I and Y as its determinants. I being the nominal rate of interest and Y being real GDP. Now, if you rearrange this, you invert this side, so you have price divided by money demand, and you have 1 divided by the liquidity preference function. And here, multiply both sides of the equation by Y. So here you'd have PY divided by M, and then Y divided by L. Over here, you have PY divided by M. That's just the velocity. So velocity to Keynes is equal to real GDP divided by the liquidity preference function. What that implies is that because increases in nominal rate of interest decrease real money demand, which increases velocity. This challenges the quantity theory of money's view that nominal income is determined by the money stock. The blue means as real GDP goes up, the demand for real money balances goes up. The fact that I is red means that if the nominal rate of interest goes up, the demand for real money balances goes down. So Y is positive related with real money balances, and the nominal rate of interest is negatively related with real money balances. This is kind of hard to visualize. For me, it's not, but for people learning this, it is. So I'm going to assume a functional form for Keynes's liquidity preference function. It's a linear equation, 0.66833 times real GDP minus 10 times I, where I is in percentages. So really, this slope is quite small because this is in percentages. Now, we're continuing with the example we used in the Fisher derivation of money demand. The price level is normalized to 1. In other words, we change the current year to the base year. And in the base year, the price level is 1 or 100%. Velocity is still 1.5. Real GDP is $15 trillion or 15,000 billion. And when we plug Y into here, we get what? 10,025. Now, according to this diagram down here, when the nominal rate of interest is 2.5%, at this dot here, real money balances is $10,000 billion or $10 trillion. If I were to take this 2.5 and plug it into this equation, what do you think I get? Well, 10 times 2.5 is 25. 10,025 minus 25 is 10,000 billion or 10 trillion. The assumed functional form of the liquidity preference function goes through this point as well. But it has a negative slope, which means that Keynes's money demand equation that I've assumed here passes through this point, but it has a negative slope. And since this is in percentages, this 10 is actually pretty small, and Keynes's money demand equation is relatively elastic relative to Fisher's money demand equation. Now, Milton Friedman kind of reworked both these models, and he came up with this permanent income idea. Y subscript P, permanent income. The way I kind of think of permanent income is an average of what GDP is today and maybe what we expect it to be in the future. But according to Friedman, permanent income links the nominal rate of interest to money demand. When the nominal rate of interest is low, people speculate it will rise in the future. So people adjust their expectations of future income upward, making money more attractive today. Now, real GDP is not very stable. It's up and down. It cycles back and forth. It cycles from season to season. So real GDP fluctuates wildly relative to permanent income, or the long-run average of current and future income, implying money demand is more stable than Keynes had posited. Now, the RB, the RE, and the pi-E. Pi-E is what it was before, expected inflation. R subscript B is the expected return on bonds. R subscript E is the expected return on equities or stocks. And then R can be thought of as the real rate of money or the real rate of interest, return spreads, the spread between this R and RB, RE and R, and expected inflation R, tend to be stable. Why? Because they kind of travel through time together. So if RB goes up by 3, R might go up by 2. The difference only goes up by 1. If equities go up by 6, real rate of interest goes up by 4, the difference only goes up by 2. These return spreads tend to be very stable, implying that money demand is not as sensitive to changes in the nominal rate of interest as Keynes posited. Because this equation is even more complex and harder to understand as an undergrad, I'm going to assume a functional form for it that is more easily understood. We're going to continue our numerical example. Here is the assumed Friedman equation. In here is what Friedman called permanent income. It is related to the nominal rate of interest. And the 15,000 can be interpreted as the average of real GDP and what we expect income to be in the future. Because the average is 15,000 billion or 15 trillion, we're not expecting our incomes to rise in the future. The bond spread, the equity spread, and the expected inflation spread are linearly related as well. I assume these coefficients are the same because I want this equation to simplify into something nice that passes through this point. When I do a little arithmetic, 10 times this and 10 times that, and I can factor negative 7770.833 from here, here, and here, I get this equation. I do that because I want to add 2, 4, and 3, R, R, and R. Using the distributive property again, I can hit this on that and that. Now I can subtract this product from that value, Also, I'm going to replace R with what it equals. According to the Fisher effect, the nominal rate of interest equals R plus expected inflation. Therefore, the real rate of interest equals the nominal rate of interest minus expected future income. Using the distributive property once again and replacing this with 3 gives this equation. And then I can combine these two together, and I can combine this with that, and I get 10,125 minus 50i. Now this is the assumed version of Friedman's money demand equation. It is steeper than Keynes's. Does it go through this point? Well, I made sure it did. When I plug 2.5% into this equation and then subtract that product from 10,125, we get $10,000 billion in real money balances, or we get $10 trillion. Friedman's money demand equation is a compromise of these computing views. Now, empirically, what does the research say about money demand? People and firms demand money because there are benefits to doing so, because doing so makes it easier to pay for things. The marginal benefit of holding an additional dollar diminishes as the amount held increases. For example, the benefit of holding $2 rather than $1 is greater than holding an additional dollar when one has $1,000. Imagine a person that is starving and they have $1. Maybe they can only buy, a Coke. If they had an extra dollar, they could buy a candy bar. When you have $1,000, you don't really have to worry about that, do you? Holding the additional dollar is also costly because you're giving up interest on a potential investment, and inflation reduces your buying power. So, the nominal rate of interest, which is the real rate of interest plus expected inflation, is the price of holding money. As it rises, you want to hold less money in your pocket or your business's petty cash drawer, which means as the nominal rate of interest rises, the quantity of money demanded falls. The quantity of money demanded increases as the nominal rate falls. Money demand increases in income, wealth, and the risk of other assets like bonds or stocks. Money demand decreases in payment technology, inflation risk, and liquidity of other assets. If Keynes is correct, money demand fluctuates with the nominal rate of interest, velocity oscillates and is unpredictable, the link between money and aggregate spending is weak, so the Fed should target interest rates, which means when aggregate demand is weak, the Fed should lower interest rates and hold them there for a while. As aggregate demand rises and then maybe potentially soars past potential output of the economy, the Fed should raise interest rates and maybe hold them there for a while. If Friedman is correct, money demand is relatively insensitive to changes in the nominal rate of interest. Velocity is stable and predictable. The quantity theory of money's view on aggregate spending being determined by M is more likely to be true, so the Fed should target money supply.